Aromatic compounds. Some of these sections are really, really short, so I won't necessarily split them up into individual videos. Just some facts about benzene. Benzene's the most common aromatic compound. Benzene is highly unsaturated, meaning it appears to have three double bonds, but it doesn't behave that way. It doesn't decolorize bromine solutions. We learned that if you mix bromine with an alkene, the bromine will add to the alkene, to the double bond, and you'll lose that brown color from the bromine. Benzene doesn't do that. Benzene is not easily oxidized by potassium permanganate, which is another characteristic of alkenes, and it doesn't undergo the typical addition reactions of alkenes. Benzene reacts mainly by substitution. That's important. And all of the 6 hydrogens in benzene are chemically equivalent. We can't tell the difference between them. They all act exactly the same. And so these observations about benzene were puzzling. And it actually took decades for scientists to figure out what the structure of benzene was. So Kekulé proposed a reasonable structure for benzene in 1865. So it seems like a long, long time ago, and yet in the history of chemistry, that's not all that early. His suggestion was that the single and double bonds exchange positions around the ring so rapidly that you don't get those typical reactions of alkenes. And so we refer to this as the Kekulé structure for benzene, where we show alternating double and single bonds. And this would be in equilibrium with this other structure where the double bonds were in a different place. And so he said, well, maybe the double bonds are just moving around the ring so quickly that none of those reactions can occur. He was nearly correct. What we understand now is that his 2 formulas are actually the 2 contributing structures to a single resonance hybrid. So there is only one structure for benzene, but it is between these. And here we have the arrows showing how the electrons from the pi bond in that between these 2 carbons can move over here, and those can move over there, and those can move over here, and we can get this structure. But the same thing can happen. And it is not that it's going back and forth between, but it is actually intermediate between them. So Kekulé drew his structures with an equilibrium arrow, saying they were going back and forth. We draw them with a double-headed arrow that indicates resonance. So the resonance model for benzene tells us that all benzene molecules are identical. There's no double or single bonds. It's not flipping back and forth. Benzene is a planar molecule, and each carbon is at the corner of a regular hexagon. So we have a regular hexagon. All these bonds are the same length, and they lie flat in a plane. Here's the space-filling model. All of the carbon-carbon bond lengths are identical. They're 1.39 angstroms. And that is between a double bond and a single bond. So these are not double bonds, they are not single bonds, they are in between. If you want to, you could think of them as 1.5 bonds, but they're in between. And this is evidence for that. Oops, didn't mean to do that.